Hello everyone. Today we will review some fundamental math skills, which will help us in continuing our study of electrical theory. First, we will have a brief introduction. Then we will review the order of operations. After that, we will look at the units and prefixes. Then, scientific notation and engineering notation. At the end, we will learn how to rearrange formula. After each topic, we will have some practical exercises. Now let's look at the introduction. Could you please try to calculate the math question on the screen? What result do you get? Can you tell which of the following calculations is correct? What matters here? Order of operations. Alright, we will review it today. We see two gas prices on the screen. Which one is cheaper, Canada or USA? Yes, the gas in USA is cheaper, even though they have a bigger number on the sign. Two different units are used here. Canada uses liter, and USA uses gallon. Units matter. The phone in the picture shows it as 28.87 GB storage. What is the meaning of prefix G? Giga, 10 power 9. Yes, prefix matters. We will also review the units and prefixes today. Here is a meter measuring the usage of electricity. Comparing the following three numbers, can you tell which one is bigger? Yes, they are all same. What matters here? Notations. The first one is in regular decimal number. The second one is in scientific notation. The third one is in engineering notation. Today we will review the notations as well. We just learned Ohm's law in the theory lecture. Can you tell which formula is correct? Yes, all of them are correct. Then you may ask, why do we use three different formulas to confuse ourselves? In different scenario, we need to rearrange the formula for calculating different variables. Yes, we will learn the skill of rearranging the formula. I know it was a challenging task for many of us. Today we will use a very simple and straightforward method to do it. I hope after today's exercise, everyone will become confident in rearranging formula. Now let's start reviewing the order of operations. In Canada, we use a short statement to describe the order of operation, BDMS. How to remember it? Try this phrase. Big elephant destroys mice and snails. What does each letter mean here? B represents brackets. E means exponent, root operation is in the same level. D means division. M means multiplication. They are in the same level. A means addition, S means subtraction. They are in the same level as well. BDMS together here means we need to follow this order to do the calculations in a math expression, namely brackets first, then exponents including root, then division and multiplication, and lastly addition and subtraction. For the operations in the same level, we follow the sequence from left to right. Now let's look at example number 1. What should we do first? Bracket. We calculate the operation in the bracket, 18 minus 15 equals 3. And copy the rest. Next step, exponent. 6 power 2 equals 36. Copy the rest. Next step, division and multiplication. 36 divided by 3 equals 12, 3 times 4 equals 12. Copy the rest. Finally, addition and subtraction. We get the final result of 2021. Remember the order of operations, BDMS. There are some useful and helpful hints. 1. Write down the intermediate results, especially in a complicated multi-level calculation. 2. Add brackets as needed, especially with the same operation function. 3. Treat fraction as division. Now let's look at example number 2. If the root function and the fraction calculation are a little bit confusing to you, you can add the brackets as shown here. Then we can follow the order of BDMS. After treating the brackets and exponents, we get this. Now we deal with the division and multiplication. Get the intermediate result here. Finally, addition and subtraction. We get the final result. Please review the whole process again. Check if you can follow step by step, or you have any question. Now, we are clear with the order of operations. Try to complete the 4 questions on your lab sheet. Alright, let's move on with the next topic, units and prefixes. Unit is very important. A number without unit is meaningless. Here are the units for some common variables. For mass or weight, the standard unit is kilogram. However, we always use pound in the supermarket. What is the conversion factor? 1 kilogram equals 2.205 pounds. For length, the standard unit is meter. We use foot in the market. For conversion, 1 meter is 3.28 feet. For area, the standard unit is square meter. We also use acre in our everyday life. 1 acre is 4,047 square meters. For volume, the standard unit is cubic meter, but we use liter every day. 1 cubic meter equals 1,000 liters. Example number 3. In a supermarket, the apple costs $1.50 per pound. What is the price per kilogram? We can interpret the question as, how much does it cost for 1 kilogram? To resolve it, we use the formula, cost equals price times weight. We start with the price, $1.50 per pound. Then times the weight, 1 kilogram. Now the 2 weight units don't match, we need to convert one. 1 kilogram equals 2.205 pounds. Now we can complete the calculation and get the price, $3.31 per kilogram. Here are the units for some common electrical variables. For voltage, we use volt. For current, we use amp. For power, the standard unit is watt, but we also see horsepower a lot. 1 horsepower equals 746 watts. For energy, the standard unit is joule, but the electricity meters in our house read in kilowatt hour. For conversion, 1 kilowatt hour equals 3.6 times 10 to the power of 6 joules. Example number 4. A motorcycle has 85 horsepower. What is it in kilowatts? Can you try it first? Here is the solution. Do you get the same result? Example number 5. A shop used 18,179 kilowatt hours electricity last year. What is it in joules? Can you try it first? Here is the solution. Do you get the same result? From the two examples here, we can see we need appropriate prefixes to present the values effectively. Here are the common prefixes used in electrical field. You already learned them from the theory lecture. Now let's review them quickly. 10 to the power of 12, tera, simple capital T. 10 to the power of 9, giga, simple capital G. 10 to the power of 6, mega, simple capital M. 10 to the power of 3, kilo, simple lowercase k. Now smaller than 1, the negative exponents. 10 to the power of negative 3, milli, simple lowercase m. 10 to the power of negative 6, micro, simple Greek letter mu. 10 to the power of negative 9, nano, simple lowercase n. 10 to the power of negative 12, pico, simple lowercase p. Let's look at example number 6. A phone has 28.87 gigabytes storage. What is it in bytes? Here is the solution. Do you get the same result? Example number 7. A capacitor has 100 μF. What is its value in farads? Here is the solution. Do you get the same result? Please review the contents regarding the units and prefixes. Check if you move along very well or you have any questions. Please complete the tasks in section 2 on your lab sheet. Now let's review the scientific notation and engineering notation. Here is a simple description of the scientific notation. The key feature is only one digit before the decimal point. After the decimal point, you can have any number of digits. However, we need to understand the total number of digits represents the accuracy and tolerance of the value. It should match with the measurement device used for it. Checking the digits used for the functions on your digital multimeter can help you get a better feeling. There is no need to ask for more digits than necessary. For the exponent, any integer can be used, including positive and negative ones. Example number 8. Write the values in scientific notation. Here are the solutions. For the first number, to get one digit before the decimal point, we need to move the decimal point to the right for 4 digits, which means times 10 to the power of 4. To maintain the same value of the original number, we need to times a canceling number, 10 to the power of negative 4. That is how we get our final result. For the second number, to get one digit before the decimal point, we need to move the decimal point to the left for 5 digits, which means times 10 to the power of negative 5. To maintain the same value of the original number, we need to times a canceling number, 10 to the power of positive 5. That is how we get our final result. Here is a simple description of the engineering notation. The key feature is that the number used for the exponent must be a multiple of 3. For example, negative 6, negative 3, positive 3, 6, 9, and so on. We can have any digits before and after the decimal point. Same as in scientific notation, the total number of digits represents the accuracy and tolerance of the value, and which should match with the measurement device used in that application. Example number 9. Write the values in engineering notation. Here are the solutions. For the first number, to get a multiple of 3 for the exponent, we can use 3 or 6 here. Let's use 6 here, since it will result in a reasonable decimal number. Move the decimal point to the right for 6 digits, which means times 10 to the power of 6. To maintain the same value of the original number, we need to times a canceling number, 10 to the power of negative 6. That is how we get our final result. For the second number, we use 3 for the exponent. Move the decimal point to the left for 3 digits, which means times 10 to the power of negative 3. To maintain the same value of the original number, we need to time a canceling number, 10 to the power of positive 3. That is how we get our final result. Please review the contents regarding the scientific notation and engineering notation. Check if you understand everything or you have any questions. Please fill up the table in section 3 on your lab sheet. Now, let's learn how to rearrange a formula. From the same theoretical rule, like Ohm's law, we often need to rearrange the formula for calculating a different variable. This is a very useful skill. We should learn it and use it. It will benefit our future career. The steps we should follow. 1. Start with the correct original formula or equation. 2. Understand the goal. Find out which variable we want to get a new formula to calculate now. Then our final goal is to have this variable of interest left at the left side of the equation, nothing else. 3. How to achieve it? We do exactly same thing on both sides step by step. What to do? Remember the goal. At the left side, get rid of everything else except the variable of interest. Let's use an example to explain it. Example number 10. From the original equation, derive a formula for calculating the variable y. Remember the goal. Keep only y at left side. Steps. Do same things at both sides. What to do? Let's check step by step. First, how can we eliminate the term minus 15? Add positive 15. There you go. Now, how can we remove the term of 10x from the left? Minus 10x. There you go. Now, how can we get rid of the factor 5 before the variable y? Divided by 5. Now we get our new formula for y. Please review these steps again. Check if you fully understand them. Please complete the 2 tasks in section 4 on your lab sheet. Now we completed our review of some fundamental math skills. Hope you enjoy it and become confident in your math skills now.